Dark, mysterious, and infinitely powerful, black holes stand as some of the most enigmatic entities in the universe. For decades, they have captured the curiosity of both scientists and the general public. These cosmic giants are known for their terrifying ability to consume everything that ventures too close, pulling matter, light, and even time itself into their abyss. Their defining feature is the event horizon, a point of no return beyond which nothing, not even light, can escape. But is their story solely one of destruction? Could black holes hold secrets beyond their fearsome reputation? At their core, black holes are not unlike any other object in the universe that possesses mass, yet their defining trait is their unimaginable density. This extreme compression leads to the formation of a singularity, an infinitely small yet incredibly massive point where all the black hole's mass is concentrated. The gravitational pull at this singularity is so strong that it bends space and time in ways we are only beginning to comprehend. While they may seem like cosmic monsters, black holes could, in fact, be gateways to deeper mysteries of the universe, hiding within them answers to the very fabric of reality itself. The more mass packed into a black hole's singularity, the stronger its gravitational force becomes. Some black holes originate from the remnants of stars that had more than 10 times the mass of our Sun. As a result, they exert a gravitational pull so strong that they can warp spacetime itself. Surrounding every black hole is the event horizon, the point of no return. Once an object crosses this threshold, escape is impossible unless it moves at the speed of light, which is not feasible. Scientists cannot determine what happens beyond the event horizon, as no information can escape from within it. The general assumption is that anything falling into a black hole would be torn apart at the atomic level due to the immense gravitational forces. However, there is a possibility of an alternative fate. Imagine encountering a charged black hole, one that harbors within it a hidden, one-way wormhole leading to an entirely different kind of cosmic phenomenon, a white hole. Unlike their black hole counterparts, white holes do not devour matter, but instead forcefully expel it. Nothing can enter them, making their existence as perplexing as it is theoretically fascinating. If such a passage were to exist, it would not be a simple or smooth transition. Rather, it would be an experience beyond human comprehension, a journey through the very fabric of space and time itself. The descent into such a black hole would be unlike anything previously imagined. As one falls deeper, reality would begin to warp in surreal ways. Light would stretch and distort, forming an eerie kaleidoscope of twisted stars and galaxies. The laws of physics, as we know them, would cease to function in their familiar manner. Time itself might behave erratically, stretching or collapsing unpredictably. As the traveler is pulled further in, they would find themselves accelerating at an unimaginable rate, crossing the event horizon and plunging into the unknown. If they somehow avoided being torn apart by tidal forces, their journey would take them through the black hole's interior, past the singularity, and into the enigmatic tunnel of the wormhole. What lies on the other side is even more astonishing. The traveler would emerge into a realm governed by an entirely new set of physical laws, where the very nature of matter, energy, and gravity could be drastically different from anything encountered before. The moment they cross into the domain of the white hole, they would be violently expelled into this strange, alien universe. Looking back, they might see the warped remnants of their original cosmos, a fading glimpse of the world they once knew. This new reality could be anything: an empty void, a chaotic maelstrom of energy, or even a thriving cosmic expanse filled with uncharted galaxies. But regardless of what awaits, one thing is certain: there would be no turning back. Before falling in, an observer approaching the black hole would witness a surreal spectacle. The surrounding stars would appear distorted, twisted around a perfect circle of darkness. However, there would be little time to appreciate the view. The immense gravitational pull of the black hole would rapidly accelerate the descent, pulling the traveler closer and closer. If one were to fall feet first, the difference in gravitational pull between their legs and head would stretch their body significantly, a process known as spaghettification. To avoid this gruesome fate, let's assume the traveler instead enters a wormhole hidden within the black hole. Unlike an ordinary black hole, a charged black hole possesses two event horizons. As the traveler crosses the space between these horizons, they might not even realize what is happening. In free fall, they would see the black void expanding before them, growing larger and larger. If the black hole were as massive as the one at the center of the Milky Way, this journey would last around 20 seconds. But under the immense gravitational forces, those 20 seconds would feel like an eternity. Upon nearing the inner event horizon, a strange optical illusion would occur. Instead of continuing to expand, the black hole would appear to shrink. This phenomenon, called relativistic beaming, is caused by the way light is compressed in such extreme environments. Light from the rest of the universe would seem brighter, forming a luminous ring around the event horizon. But as the traveler moves past the inner horizon, another spectacle awaits. A powerful burst of energy would suddenly illuminate everything. But this would not be an ordinary flash of light. Instead, the traveler would witness a projection of the entire history of the universe reflected through the singularity of the black hole. This visual phenomenon is due to the extreme warping of space and time. As they move deeper, they would continue their journey through the wormhole, leading to the white hole on the other side. Yet, this passage would be anything but stable. The immense gravitational forces at play threaten to collapse the wormhole at any moment. If the traveler manages to survive, they would witness a second burst of energy, this time showing not the past but the future of the universe. However, this future would be entirely different from what they once knew. They would not simply emerge in another region of space but in an entirely separate universe with its own unique laws of physics. Finally, the traveler would be expelled from the white hole, finding themselves in an unfamiliar cosmic expanse. Looking back, they would see light from their original universe trailing behind them, carried along for the journey. They would be the first person to explore an entirely new reality. This new universe could contain astonishing discoveries, perhaps parallel versions of themselves living entirely different lives. However, there would be risks. The laws of physics in this new realm might not be favorable. Gravity could be weaker, stronger, or even non-existent. The very fabric of matter might be composed of dark matter or antimatter. If the latter were the case, the traveler would face immediate annihilation upon contact, as antimatter and ordinary matter annihilate each other in a burst of energy. Worst of all, there would be no way back. White holes, unlike black holes, do not pull anything inside. Instead, they relentlessly expel matter and energy, acting as a one-way exit to an unknown cosmos. A traveler emerging from such a phenomenon would find themselves utterly isolated, with no means of retracing their steps. The very nature of a white hole dictates that nothing can enter, making the prospect of a return journey physically impossible. This means they would be permanently stranded in a universe that may operate under vastly different laws of physics. Gravity might behave unpredictably, time might flow at an unfamiliar pace, and the fundamental particles making up matter could be entirely foreign to anything previously known. The traveler might even find themselves unable to interact with their surroundings in any meaningful way. With no resources, no technology, and no way to communicate with their original universe, survival would be uncertain at best. In essence, stepping into a black hole with the hope of emerging from a white hole would be the ultimate gamble, one where the stakes are existence itself. While the idea of traveling through a black hole is fascinating, the dangers far outweigh the potential rewards. Perhaps it would be wiser to simply observe black holes from a safe distance. But what would it look like to gaze into the depths of a black hole without falling in? That, however, is a question for another time.